क्या आना जीरो में?
Hi, I am Monica. Today I shall be taking up the topic of arithmetic progressions. Now, before defining arithmetic progression, I would like to take a few terms. Now, first of all, I shall be defining what is a sequence. Now, what is sequence? It is an order of succession of numbers by a certain definite rule. Like, say, example, I have the terms like 2, 4, 6, 8. Now, in this is a very simple example. In this, we observe that each term is obtained from its previous number by adding 2 to each of the previous terms. So this is known as a sequence. Now there are two types of sequence, that is finite sequence and infinite sequence. As the name is indicating, infinite sequence, if the number of terms are finite, it is said to be finite sequence, and likewise the number of terms are infinite, it is said to be an infinite sequence. Now next I shall be taking up the term as series. Now what is series? Now if we denote the terms like this is T1, this is T2, this is T3, likewise up to Tn of the sequence. Now if we add all these terms, say if we add T1 plus T2 up to say the nth term, so this will form the series. Next I shall be taking up the definition of progressions. Now what is a progression? If the terms of the sequence are defined under certain specific conditions, it is known as a progressions. Now progressions are again of three types: AP, arithmetic progressions, geometric progressions, and the harmonic progressions. See, these are defined as AP, GP, HP. But presently I shall be taking up only arithmetic progression. Now what is an AP? Now the terms of the sequence are said to be in arithmetic progression if the difference between any term and its previous term remains constant throughout the sequence. It is known as arithmetic progressions, and this constant is defined by this common difference. It is represented by D. Now say example, if we have the term, say this example only, say 2, 4, 6. In this we observe the difference of the terms of the second term minus first term. It is again equal to 2. T3 minus T2, it is again equal to 2, likewise so on, T4 minus T3. Now the difference, that the common difference, it remains constant throughout the sequence, it is known as an AP. Now how to find a general term of an AP? Let us take up that. Let us say T1 denotes the first term, let us say it is equal to A, and as we have just discussed, D is a common difference, so T2 will be, it is just A plus D, and I can write it as A plus 2 minus 1 into D. Likewise, T3 I can write it as A plus 2D, or I can simply write it as A plus 3 minus 1 into D. So here what we are observing is, whatever subscript is there, we are writing here that one, like 3, so here it is also 3. So continuing like this, we can find the nth term, and Tn will be, on observing this pattern, it comes out to be A plus n minus 1 into D. So, if we have to find any term of an AP, we should know the two terms. We should know the first term, we should know the common difference, then we can find any term of an AP. Right? Now, next I shall be taking up how to find the sum of n terms of an AP. Say, Sn denotes the sum of n terms, and let us say A be the first term and L be the last term, and say D is the common difference. So, how to find the sum? Let us say it is A, the term number, sum of the terms A plus D, A plus 2D. Likewise, continuing like this, it is up to L. L is the last term. Now, rewriting it in the reverse order, like L should be written first and A should be written in the last. So, here rewriting in the reverse order, what we will observe is, it will be L, L minus D. Likewise, continuing L minus 2D. So, I can write it up till A. Now, adding 1 and 2, what we will get? 1 plus 2. We will get twice of Sn. So what will get? A plus L. Likewise, continuing, this will be again A plus L. Likewise, so on, it will be A plus L up to n times. So sum of all these terms will be simply n into A plus n. So hence Sn will be n by 2 into A plus L. So L is the last term that we have just find out over here. So putting up the value of L over here, what we will get? N by 2. On solving it, it will come out to be n minus 1 into D. So depending upon the question, if we are given the first term and the last term, then if we are given the first and last term, we shall be using this formula, and if we are given the first term and the common difference, we shall be using this formula. So next I shall be discussing about the properties of an arithmetic progressions. Now first property, say if we add or subtract a constant difference, a constant number to each term of the given AP, the resulting sequence will again be in AP with the same common difference as that of the given AP. Likewise, number 2, if we multiply or divide the given AP, the given terms of an AP, the resulting sequence will again be in AP, but the common difference will be lambda or 1 by lambda times as that of the given AP. Right? Number 3 property, say if the terms of an AP, the sum of the terms of an AP that are equidistant from the beginning and the end, it is always constant and it is always equal to the sum of the first and the last term. Say what I am saying is, if the terms are, say, we are having A1, A2, likewise so on. Now the sum of terms equidistant. Equidistant matlab first and the last term. A1 plus An, it will be equal to A2 plus An minus 1. It will be equal to A3 plus An minus 2. Likewise so on. And this will always be a constant and it is always equal to the first and the last term. So let us explain this with the help of an example. Say if you are given, say A1, A2, there are 24 numbers and they are in AP. And we want to find the sum of terms of all these 24 terms of an AP, and we are given that A1 plus A5, A10 plus A15 plus A20 plus A24, it is equal to, say, 225. And we want to find the sum of the 24 terms of an AP. Now using this property, how we can find, as we just discussed, the sum of the terms which are equidistant from the beginning, yani ki A1 plus A24, A5 plus A20, A10 plus A15, I can write it as A1 plus rearranging A5 plus A20,
6 minutes.
A10 plus A15 is equal to 225. So now I just explained that the sum of the these equidistant terms is always constant and it is equal to the sum of the first and the last term. So I can write it as this as A1 plus A24. This can also be written as A1 plus A24. So this becomes 3 times of A1 plus A24. Hence it is 225. So we observed A1 plus A24 is equal to 75. Now we want to find the sum of the first 24 terms of AP. So using this relation, the sum of n terms, Sn is equal to, so this will come out to as 24 will be equal to 24 by 2 into A1 plus A24, that we have just find out. So solving this, we will get the value as 12 into 75, which is, say, 900. So that is how we can find out the sum of the first 24 terms of. Hope you like this video and thanks for watching it.